and divide that both take in two integers and return an integer. And then I have my struct
Okay.
that a struct that contains as elements first is a function pointer, a pointer to a function that takes in two integers and returns an int, and then a character is a character.
The sign.
So yeah, sign, the sign exactly.
Mm.
Then the last function I have here is the function calculates that actually does the calculation. So it takes as argument, um, an int, another int, and
And a
then
function pointer.
yeah, a function pointer.
Mm.
So the arithmetic functions are pretty simple. Just add two numbers, subtract two numbers, multiply or divide, and then it all comes together in the main.c. So so I have an array
An array of structs.
of structs. Yeah. And well, I'm using the scanf function to receive, the two integers and the sign as well.
Okay.
Just, switch things up. Then next is I'm trying to find out which of the signs was imputed, and depending on the sign. So depending on the sign, as we iterate, I'm iterating through this array of structs. And if I find one that if I find that sign, the sign that the user impute responds to any of these signs in the array, then I'll just go ahead and pass the function, you know, that corresponds to that sign in the struct. So if it's a plus, it will take I'm going to pass the function add.
Add
If it's
subtract.
yeah, so I'm going to pass it to calculate. So that way, the function pointer, which is the second argument of the function calculate, now points to whatever function that is.
It's being
Uh,
asked.
yeah, and then the calculate function does its calculation
Let
and
me
then
ask, have you
return.
have you uploaded this code to GitHub?
No, I didn't.
Because the way it seems really interesting. I actually would like to take a look at it. I'm doing
That
something similar. And then so
yeah, probably I'll just put it up to GitHub. Now you've talked about it.
that
So yeah,
would be good. So
yeah.
let's see. We enter the first operand.
Yeah, so
So how do you ensure that you've looped through the oh
through
I
the
see.
array, you know, it's an array, so it has a specific size.
Yeah.
This
I see it.
specific, yeah,
See it now. So that way you ensure that each element gets a part.
yeah. The only thing I've not implemented edge cases, but well, there's always time for that. I've not implemented edge cases. For example, what happens if something apart from these symbols is imputed? So let's
Mhm.
run the code first of all.
In
So enter.
that case, it's undefined.
Yeah, it does that. That's what it does. It produces undefined behavior. So let's say we have 500, and then
Plus
so say plus
200.
two, 200. So
That
we
gives you
just
700.
yeah,
But then you do realize I can tell you another bug that you haven't. If this was to be run on the Linux shell, like a Bash shell or a Unix shell, like the C
yeah,
shell or the Con shell, the
yeah,
multiplication, the
yeah.
asterisk. Yeah,
Oh, it has a problem.
unless somebody
Yeah.
uses the escape character sequence, it would expand to include all the files present in that particular directory, and you see that how that would be a problem.
Wow. Yeah, I see that. Yeah, that's true. Because it's a special character.
Yeah, it's a special
Uh,
character. Well, that problem you can't solve it on based on using your program because it's a shell problem. I remember once we were trying when we were learning about static libraries. I tried to do
yeah,
something similar and I encountered the problem. Unless somebody uses an escape character, I don't see how he'll do it. But then the major problem actually is that since the wildcard would be expanded before your program is run, well then there's no way to fix it from your program because it will be expanded so that the input your program receives is not.
yeah,
However,
yeah.
but then why don't you just try it? Because I'm thinking about it and I'm seeing because you'll be taking the input yourself. Why don't you try to run it and let's see how what will happen?
On the Linux shell, right?
Yeah, yeah, on the Linux shell.
Okay. Let me copy all these. Oh, good thing I'm using Windows subsystem for Linux now. What do you use?
I use the web terminal. I can't afford my laptop,
Oh, okay.
so
That
I have to use a borrowed one.
that's all right. So the sandbox works perfect.
Yeah, the
Thank God for
sandbox
the
for me.
sandbox.
It's always the
Yeah,
sandbox for me,
yeah.
and it's web terminal.
I only started using WSL actually. I've always been using Sandbox. I used the Sandbox all through my Sprint one. Um,
I see myself using the sandbox all
all
through
through,
up to specializations
yeah,
and
that
maybe then
works.
after.
That works. Thank God we have the Sandbox. So
You're a VI user. You love VI so much.
I'm trying to switch to Emacs. I'm trying to find out what Julian. I think you're an Emacs guy too.
Yeah, I'm an Emacs guy. I mean, Emacs is just better. I don't know why you guys love it.
Yeah, I'm trying to learn the Emacs commands, and actually, I feel like Emacs is more serious or more customer friendly because I mean they have a whole tutorial on Emacs on how to use Emacs, and Vim does not care about you.
Maybe it's, but you see, Emacs is much more powerful. You can always recustomize your Emacs using the Lisp language, Emacs Lisp. Emacs is it's just better. I mean, from day one, I was always an Emacs guy.
Well, I know that there are a lot of things you can do on Vim too. I just don't know how to do them, but um, I mean, there has to be a reason why Julian is Team Emacs. There
Well,
just
let's
has
set.
to be. And for me, I want to find what that reason is. And then
Okay.
I've met a few Emacs guys too, like you, and then my printf partner, he's Team Emacs too.
Hmm. Emacs is just way better. I don't know how to say it even worse than.
Yeah, I'll find out. Hmm.
Okay. Hmm. Today I was looking back at pointers, and I think
Okay.
I think on just pointers, I'm relearning pointers. I want to ensure I understand pointers by the end of next week. I want to ensure I completely understand pointers in C.
Yeah. Did you find anything new?
No, not something new. It's just that the task seemed harder. For example, how to if you are adding an integer, how to store those values in an array, because today as when you're adding an integer, you'll begin from the
Yeah.
ones digit, right?
Yeah. Yeah.
So
When
that's the
you
last digit. So when you're storing it in an array, you'll be storing it in the last digit, in the very last digit, but then when you really look at it, you can't. How do I say this?
You can't.
When you're printing it, you'll have to print it from the first digit, from the 0th one. Did you try the advanced tasks on the pointers project?
No, I'm actually going back to. I'm revisiting all those.
Advanced tasks.
Yeah,
Okay.
all those tasks. The ones I didn't do, mostly advanced tasks. I didn't do. Like there was this one. Probably since you're doing the same thing, I would ask you about them. There was this one I didn't do a lot of tasks with pointers. I didn't do a lot of tasks. The advanced task. Do you know that there was the very last pointers project?
The even
I
more
didn't.
yes, what about
Yeah, I didn't do it at all.
it? Well, I've been doing it today.
I didn't do that at all. So I'm revisiting all those tasks. Uh,
Extra error. Oh, you don't have to use the C89 standard. I mean, this is a personal project, not Alex.
yeah, yeah, true. Um, you for real? Comparison of integer expression of different signs, long unsigned, size of okay. Yeah, it's things like this. Sometimes these are few of the disadvantages of
The flags.
oh well n- I'm not even trying to say the flags, but of Replit.
Replit doesn't
Because
give you those errors.
there's some things it would let slide.
Okay, I see. But
There's some things. Should I just typecast it?
you could do that, right?
Is there any other place I use it? It's going to make this line longer if I typecast it.
No, no, no. Why don't you just declare it as an unsigned integer? You're always starting from 0 anyway. Long unsigned int.
Yeah, that's what I'm doing. Okay. Sorry, you have a cold.
I have a bad cold.
Oh, sorry about that. It's that time of the year.
No, it's from the traveling. All the traveling yesterday. Yesterday and the day before yesterday.
Okay.
No, with command line arguments, your program will be interacting with the shell. It will be taking arguments that are given on your. In this particular case, your program runs, and therefore it takes control. The shell, it's like a process, like a child process of the shell, right?
Yeah,
Yeah,
it's a child process. Yeah, it's a child process of the shell, but it's the current process. Like
yeah.
while it's being executed, it is the current process, like at the top of the
So the
stack.
thing is, with command line arguments, it's still the shell that is running when you're giving it.
Yeah, exactly.
Why don't you upload this code to GitHub? I'd actually like to modify it to make it
I'll
be
do
able to
that.
take command line arguments.
I'll do that. I'll do
Okay,
that.
fine.
I'll do that, and I'll let you know.
Function pointers. So let me see where people are. Where are they not coming?
Alright. I, okay. I saw a message on Slack that you wanted to take a class on the struct and function pointers. So that's why I joined.
Oh,
Yeah,
that's
you're
fine,
welcome.
Austin. Daniel would be happy to take you through those topics.
Yeah, sure. So you're our first
All
participant
right.
for the night. How has your printf project been?
I understand
Us-
you're almost getting done with the printf project. Austin.
Uh, your mic is muted.
He's muted. Austin, you can unmute yourself. Austin?
Okay, I'm having network issues here currently, so that's why I can.
Okay, fine.
Okay. Well, it's all right. So you have the privilege of being the first participant. So we can make this an interactive session,
For you,
personalized session until we have
more participants.
other, yeah, until we have more participants. But
Okay. Okay, the thing
yeah,
is, what I've actually I've done task zero, not the normal, the C and S
yeah,
formatter. So the thing is, for my codes, they are up to 40 lines, and Betty keeps saying your codes not be more than 40 lines. So I say there's no way I can add the ones for the D and the I and other stuff. That's why I have to learn the function pointers and struct and
Hmm.
see a way, if there's a way that I can make my split my codes into different functions using struct and function pointers. That's just
okay,
it.
all right. Prior to that, what did you use? How did you implement
Uh,
your code?
okay. Do I did it? I did the function. I did it. The normal putcar. I did the normal putcar function to print characters.
Yeah.
Then I did the put function to print strings. Yeah. So,
Okay.
so I use the normal switch case. So case C,
Okay.
I use a put print. Case S, I use puts to print, and so it's majorly just switch case and those functions. I use helper functions I add. But there's no way I can continue adding more cases. That's the thing.
Okay. So you're using a switch case, and all right. So
Yeah,
it's good that you learn how to use function pointers, and an array of structs. And I'll show you how in this meeting. But I'll also like to tell you that there is a way that you can make your code work. I like to build on people's codes. Like I like people to see their codes to completion. Okay, and there is a way to make your code work. Um, but well, let's go ahead. So a simple way to make your code work, there's a possibility, and if we have the time, I might be able to show you right here. You could split your switch case into two helper functions. So if this first helper function returns one, that means that one of the cases in that function is actually true, and so let this second function that contains the remaining switch cases, let the function not be called. However, if
wow.
the first one returns zero, then call the second function, something like that, just off the top of my head. So we can try to implement that, today, but it's also going to be good for you to learn how to use, an array of
Okay.
structs and function pointers.
Okay, sorry. I don't know if you could still learn that today, maybe after because it's very important, truly, like you said.
All right. So do we start with that? I mean, it's just the two of you here, and both of you want to learn that. So I mean, there's no need going on to do function pointers and all when the both of you have a more pressing need.
Yeah, I mean, if you have a more pressing need, but then with the Austin wants to know about the I mean the implementation using function pointers and structs is actually more efficient. And
Yeah.
but then I think you're right, Daniel. We should just go with their codes so that we see how we can help.
No, I would also like to learn function pointers and struct too.
Okay.
Okay, fine. Daniel will be taking us through that.
All right. All right. So at this point, I'll share my screen, um, and then we'll begin. You're going to meet a recursive page for a few minutes. So don't mind that. And here we go. Okay. So I'm using I'm using an online C compiler called Replit. I I enjoy using Replit. It makes things a lot easier. Okay, and it's like my place, my workstation, my PlayStation rather. So here I have an already written function. Okay, and I'll walk us through it. This function, this program is implementing function pointers and an array of structs, and I would like for you to use your imagination and relate this. I made it in such a way that you can, if you use your imagination, relate it to your printf project. Okay, so here we have four functions. Okay, add, subtract, multiply, and divide. Each of these functions, they take in two integers as arguments and they return an integer. I mean, you can imagine. So the add function, this is where I define the functions. The add function just adds these two integers and returns the value of the addition. The subtract function does a subtraction, multiply does a multiplication, and the divide function does a division. Now, we have in our main.h a struct. Now, if you remember how a struct is defined, okay, I'm doing the type definition and the definition of the struct at the same time. Okay, so I'm type defining a struct called arithmetics, which takes in two elements. The first element is a function pointer. I'll come back to it shortly. The second element is a character called sign. And then the name of the type def. So I'm type defining this to arithmetics underscore t. So instead of saying struct arithmetics, I'm going to be using arithmetics underscore t. Now let's come back to this function pointer. Let's look at the syntax. Okay, so we see here, first of all, an int, and then in parentheses we see asterisk func, and then in another parenthesis we see int comma int. Now, and I'm saying that this is a function pointer. If you remember your syntax of function pointers, func is the name of the pointer, just like any other pointer that you know. Func is the name of the pointer, the name of the pointer variable. Okay, and so this asterisk here in declaring this function pointer is just telling you that it is a pointer. Now, this is how you know what it points to. It points to a function that has two integers as argument. So this second parenthesis here tells you the arguments that the function. Sorry, can you mute yourself so that you don't disturb the.
Okay,
All
Daniel,
right,
you can continue.
all right. So this second parenthesis tells you the arguments that the function that the pointer is pointing to, the arguments that that function takes. So we have a pointer that points to a function that takes in two integers as arguments. And now this int at the very first place simply tells you the return value of this function that the pointer points to. So this our function that our pointer is pointing to returns an int. Now that's about this struct. So you would notice already that our function pointer can point to this add function because the add function takes an integer, two integers as argument and returns another integer. You would also notice that these other functions can be pointed to by our function pointer because they are they all have the same architecture, they all have the same structure. And this is what we're trying to achieve here. Okay, so I'm letting you know that our function pointer in this struct can point to all these functions highlighted. Now that leaves us with one function, this calculate function. I Okay, let me just go ahead and talk about it. Now we have seen how a function pointer is declared. But if you remember when you were learning about function pointers, you can also declare a function that takes in a function pointer as argument. Please don't get confused by the number of times function is being mentioned. Just follow me. So we have a function here. Thank God for Replit. It's highlighting all the functions in a shade of yellow. So that's tell us that calculate here is a function. Now, in this, well, okay, let's talk about the easiest part. It returns an integer. Now, let's go to the more complicated part. What is in this parenthesis? Just like with any other function, in the parentheses, we're supposed to see the arguments that this function calculate takes. Now, follow the comma, follow the comma symbols. That is supposed to separate the different arguments, right? So here we have an int. First, one argument, an int. Second argument, another int. Now, what is the third argument? This whole thing here is the third argument. Now, I want us to compare this with what we have here that we said is a function pointer. The only difference is that here we wrote func and here there is nothing written. And I could as well go ahead to write func here. Really, it doesn't change anything. It's just the same way I could write int A and int B here. Okay, and it doesn't change anything. It's just how I chose to declare my functions, the function prototypes. So don't get confused by this. This is just telling us that this function calculate takes in two integers and then a function pointer. What function pointer? This function pointer. All right. Now let's go to our main.c where everything comes together.
So, sorry, I have a question.
Yeah, go ahead.
Okay, so you say so we don't need to kind of input our variables like the hint A and hint B. It's not important, right?
Yeah, it's not, but I mean, if that's what you're used to, please, I don't want to confuse you.
Okay, okay, okay.
So if it's what you're used to, I'll just put it. It's something that you were taught when you were being taught some prototypes,
Yes, yes.
but you probably don't remember. So this is the same thing. It doesn't matter here. Where it matters is where you're defining the function.
Don't forget B. Yeah.
What do I do here? It really does not matter. So it's the same thing. But now here that I'm defining the functions though, let me just show you. Thanks to Replit. If I do this, you would see that it's showing me this yellow wiggly lines. So it's saying omitting the parameter name in a function definition. I have to put in the parameter name in a function definition, but not in the function declaration. It's up to me whether or not to put in the variable name, the
Okay,
parameter name in the function declaration. All
okay.
right. So moving forward, we've included our main.h. We have Okay, so we have our main function now in main void. follow me. We'll come back to this. Okay, we have two integers a and b. Now I'm using the same name a and b so that you can relate what it could be. All right, but we'll find out soon. We have another integer value and another integer I. I'm going to use I as an iterator. Then we have a character sign. Again, I'm using the same name function, the same variable name, just so that you can have an idea what it would be. So just think of it as this, and think of a and b as the integers that are going to be passed. So a function pointer. Now, another concept, we have an array here. Now, remember how an array is declared. If you have an array of integers, first of all, an array takes in the same data type, okay, elements of the same data type. So if we have an array of integers, you're going to have int, let's say the array name is arr, like we have here. So we have int arr, and then square brackets, and you can go ahead to initialize your array if you want to at that point. The same thing if we want to declare a character array. Now we want to declare, and we have declared and initialized an array of arithmetics underscore t. Now, what is arithmetics underscore t? Remember that it is our struct. Okay, we type def our struct arithmetics to arithmetics underscore t. So what we have here is an array of structs. I mean, we can have an array of anything, and here we're having an array of structs. Okay, and this is how we're initializing our array. So remember that our struct takes in, first of all, a function pointer, and then a character sign. I've told you, we have explained how this function pointer can point to these four functions. And now we're initializing our array. The first struct takes in a function add, and then a character. In our case, is the symbol plus. So you can imagine what we're trying to do already. Okay. Now note that we have here a function pointer, a pointer. And so ideally, what we're supposed to have here is an address, because a pointer always points to an address. So if we have a function pointer, what we're saying is that we have a pointer that points to a function. So what we should have here is the address of that function. However, the name of a function is the address of the function. I hope you remember that. That is why we can do away with the ampersand symbol. The truth is that we can leave it like this, and this works too. But I mean, since it's not really necessary because the name of the function is the same thing as the address of that function, this is why this works, okay, without the ampersand symbol. And so we have initialized an array with four structs: add, subtract, multiply, and divide, and each with their corresponding symbols, which are of character data type, that we're going to eventually use to link an operand to a certain function. So if we see the plus symbol, then we're going to call the add function. Let's see how that works. Now, something that we don't do quite often in ALX is receiving input from the user. We've done that with command line arguments, but here I'm doing this with the scanf function. Okay, you probably understand it, but even if you don't, you can understand it now, or you don't have to stress yourself for now. Maybe if you want to just focus on printf. But I'm saying enter the first operand, and then this integer a, remember our integers a and b, and then our character sign. So a receives the first operand. The first operand is just the first value that is going to be operated on by the operator. So maybe 5 plus 5. 5 plus 6. 5 is an operand, 6 is an operand, and then the plus is an operator. So the first operand is stored in A. Now the operator is stored in the character variable sign, and then the next operand is stored in the integer variable B. Now here in this we have a for loop. Okay, what does this for loop do? I'm telling you that this for loop is going to iterate through our array just the same way you usually iterate through an array. It's not something you're not used to. Okay, well, basically I'm trying to find out the number of elements in my array by this statement. Size of array over size of array 0 is just going to tell me, okay, this is how many elements in your array. So as long as I is not equal to the, so we're basically saying from index 0 to the very last index. Okay, now check this. If sign is equal to array I dot sign, remember that array I goes to a struct. Okay, so in case of array 0 is this struct here. Array 0, for example, dot sign. Remember our struct definition here. The second element is sign. Now, whilst you're used to the hyphen and then the arrow symbol, that is when you have a pointer to a struct. I'm just using the struct. I'm not using a pointer to a struct. So remember how we access elements in a struct. Okay, so array I dot sign is saying this whole statement rather is saying if the character we take in, if the operator we take in is, if we find that it's the same as array I dot sign, so maybe array 0 dot sign or array 1 dot sign, till we get to the end of the array. If we find a match, then what do we want to do? Remember this, our calculate function. Okay, calculate takes in two integers. Now we are passing the two operands A and B, and then we are passing the function array I dot func. So the corresponding function. So if we find that sign is equal to plus, is equivalent to plus, then let's call the function add. If we find is equivalent to subtract, let's call the function subtract. Okay, and this is our calculate function. It simply performs the operation func, whatever func is A and B, just perform that operation and return the value. Okay, return that value here, and this is what we are printing. That's basically it. So now let's run this and see how it works, and then we'll take questions. So this is another reason why I like Replit. It allows me to use the console to check my output fast. So enter the first operand. Let's see, 500. Now enter an arithmetic operator. Enter a plus symbol. Then enter the next operand. Let's see, maybe 250. And it produces the result. Let's try this again. Enter 600. Let's do a division symbol. And over 2. And it works. And just like that. Now note that I have not handled edge cases like let's say a symbol that is not one of these is entered. What happens? Let's see what happens. No, let's use this. And you see, so this is an undefined behavior. I'm not the architect of this. All right, so I've not handled edge cases. In trying to deal more with this code, I could handle the edge cases, but for now, just wanted to focus on showing us how this works. Now, if you have, like I told you, I told you to use your imagination. You would find ways that you can use this in your printf, to make
Okay,
this
so
work.
okay, sorry, please. I just have a question, just
Yeah,
one question.
yeah, go ahead.
Okay, thanks. So about that function calculate. Sorry, can you just kind of shed more light on it? Sorry.
All right. So
Yes,
I
thanks.
told you that calculate takes, first of all, two integers and then a function pointer. Right? Now, remember that here we're passing a function. So it's just like when you have no, I'm not going to use a character pointer. X. Sorry, I'm missing some. Okay. Ampersand. Mm, yeah, ampersand A. Let's imagine that A is an integer. Okay, and we're saying an integer pointer. We're assigning it. So we're assigning the address of A to it, and I'm telling you. So what am I trying to explain? Now, in this situation, I mean, you've worked with pointers a lot across different functions in your ALX training for you to know that when I say this, okay,
Yes, yes,
this is the function details. This is the function, well, definition here.
yes.
It This argument is a function pointer, and when I am calling the function calculate and then passing a function to it or the address of a function to it, and basically this is basically what I'm saying. Assign the pointer, assign the address of A to the pointer X, assign the address of whatever function this is to this function pointer, so that when I now say this func, because func is already an argument here. When I say func a b, it goes to call whatever function that I passed here. So if it is sum, if it's add, it calls the add function and performs whatever this function does on these two integers, which I have passed here as arguments to the whatever function this is. And this only works because func as a function pointer takes in two integers, and all these functions here, all of them taking two integers as arguments. So if we had a function that takes in an integer and a string, for example, then I don't even know what the behavior is going to be. Okay, but it's definitely not going to work with this. I can't pass it to this function pointer. So at first I initialize an int an integer variable value, okay, to 0. I just do that. I mean, I could just declare it this way, but I decided to initialize it, and then I'm assigning whatever the return value of this function. Remember, this function pointer here returns an integer. And remember also, all these four functions here return an integer. So whatever the return value is, then pass it to this variable value. And then that is what I'm returning. Okay. Now, this is where I'm calling the function calculate in my main.c. I mean, I could have afforded to put this somewhere else, maybe in this file. I could have afforded to put this calculate function definition in this file, so you will not be seeing it. And then all I would have here is my main.c. But well, it's my code and I chose to do it this way. This is what I'm telling you about. I was telling you guys about your printer being your code, and you do with it whatever you want as far as you get the required outcome and you're learning standard ways of doing things. right? So the return value of calculate, which is actually the return value of any of the function that eventually is passed to it here. This is what I'm passing to value again. Again, I like to use the same variable names just so that I'm sure about what I'm doing. Okay. And this is what I'm printing. I hope this makes sense. You need more clarification.
Yeah, yes, I think I'm getting you. I'm actually following. I'm getting a lot.
All right. So any other questions? Any more questions on this? Any more questions before we go to how we can use switch case statement to achieve this too?
Okay, go on. I think there are no questions today.
All right, that's fine.
Okay, sorry, I don't know if you could help, like send these codes to us. I don't know. Since
Um,
it will be very useful for study when we are trying to kind of.
yeah, it's going to be on GitHub. So
Okay.
I'll probably just make it available on GitHub. All right. So Samuel,
Yes,
what
Dennis.
do you think? Do you have anything to share with us?
No, no, a moment. No, 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 no. I'm good. I'm good. You've done it just fine on structs and function pointers.
All right. So I don't know. Do I go ahead and talk about how we could do the whole switch statements into functions?
Yeah, do that. But and then just remember to show Peter. Peter was wondering how he implements printf in less than 40 lines of code. That
Yeah,
was your worry, Peter,
yeah,
right? Peter.
yeah. That was true.
Yeah. Yes. Yes. True.
Okay, so just
All
write
right.
switch case statements. So how to make the choice and how to execute them in different files and different functions.
All right. Perfect. So let's do that. So let's go to suggest opinion because I'm advertising a piece. So I love this because I can have different. It's called different records. So I'll just show you. So with this, I have a new working document. Everything is saved. I have all this in my repos. So I'm going to do some copying though. Right. Let's create this simple. Give me some time.
Okay. Okay. No problem.
All right. Function. Wow. Okay. Main dot A. Let's just copy it. Okay, but this one we won't need this structs, and probably won't need this too. Yeah, we won't need this too. All right, so now to our main.c. I'm going to create two functions. All right, let me deal with two functions first. So what I want to implement, here's what I want to do. Okay, we have two, we have four functions. All right, I'm going to split. I would like to do a switch case statement, all right, that checks for symbols, but I'm going to split my switch case statement into two switch case statements, each being in a separate function, just to give us an idea of what I had talked about. I've not implemented this before, so let's see how it works. It takes in, what does it take in? It takes in a character. Okay. Put this in our main.h. All right. Where do we start? Well, let's just expand these first. So let me declare I'm going to return this variable. Yes or no. Now switch. I hope I remember. I always forget the syntax for switch cases. I hope I remember. Please, if I make a mistake, correct me. So now, here's what I want to do. Obviously, if we get an addition symbol, a plus symbol, we're going to call the add function. If we get a minus symbol, we're going to call the subtract function. These are the two that I want to put in this first switch, in this function, first switch. So case plus, there's a problem. Okay, case plus, call the add function. Add subtract. Okay. Oh, okay. So there's another thing about not being sure what you need to do until you start writing your code. Well, unless you write proper pseudocode. In this situation, I didn't write any pseudocode. Now I see that I want to call the function add if I encounter a plus symbol. I can already see that for this, I would need to bring in my two variables, my two operands, okay, A and B. So I'm making a change to the definition of my function. Okay, it's going to take int A and B. Again, like I said, it's your code. You can do whatever you want to do with it. And obviously, I need to I need to receive well, I need to receive the return value. Most likely, I'm going to need it. Obviously, I need to break and then case minus same thing. Or let me just break. You may or may not want to have a default statement. In my case, I don't really need a default statement because if none of these works, well, it doesn't work. Fine. Do I need a default statement? No, I don't. But what I need is to change the value of yes or no. So if any of these functions, if any of these cases is if it comes to play, if any of these cases come to play, change the value of yes or no to 1. Think of it as a switch where 0 is off and 1 is on. So I will return yes or no. Now I quickly have a situation. How do I deal with whatever the value of art is? And I have to print it from here. I might have to print it from here because I'm returning yes or no. Mm, okay. So like I said again, this is how you just build on your code based on what you see that you need. Like I said, I've not done this before. I'm doing this right here before your very eyes. Obviously, my second switch case function is going to have the same requirements apart from um, multiply, divide, and let's change this here. Please, if you're not following me, just let me know.
No, I'm actually following now. I'm actually following.
All right. Now you see that this is supposed to stop. What's the problem? Conflicting types. I fixed the problem, bro. Yeah. Yeah, fix it. All right. Is there anything I'm missing? I don't. Yeah. Yeah. All right.
I
So
think
let's go to our main.c and bring everything together. Um.
Peter, I hope you're following, right?
I am really following. I think I can actually imagine what it's trying to do. So we can use this to break our functions, break our switch cases
Yeah.
in our
Yeah.
printf
Exactly.
function.
So that you call
So
the
you now
function
have.
that you need as you need it.
Yeah.
Okay. So, no, let me just copy it. Come on, I saved it, bro. So I want to copy the whole requesting for input because I'm lazy and I don't want to repeat myself.
Yeah.
Acha hii meeting iishe. Fanya interview, then you ndio printf.
Okay, so what do I need? I need now this code. Then I can even use another statement here, or I can let an if else statement. How do I do that? If second switch, first switch. So I don't know. Well, let me finish doing this and then I'll ask.
Speaking of Daniel, could you send the link to the GitHub repo, the file that you've just been using? Could you send it a link to read in the chat?
What can I do? I've not put it on GitHub yet.
Okay, fine.
Yeah, but I can send the link to this replit. You can look at it. You can fork it, and well, I think GitHub will be easier for you guys. But before I leave here, I would send the link to this replit, and then I'll put it to GitHub and leave
Okay.
the link
Okay. Okay. That
sign like that.
that would be nice. Thanks.
All right. Character int. Character int. All right. So if this is not the code before. Don't get confused here.
No worries. I get.
Sorry. Um. So I think that's it. Am I missing anything? Is there anything you've seen I'm missing?
meant I think you're saying if first switch is true,
Yeah,
then it should return zero.
yeah.
Okay.
I'm basically saying, just I'm done.
Okay.
When I say this,
You say
actually going to, when I say this, it's actually going to call the first switch function.
okay.
Yeah. Let me simplify this. So,
That's an interesting implementation.
sorry?
Yeah, it is. It really is.
Sorry, someone. So, I'm receiving the return value of first switch instead.
Yeah, exactly. Yeah, that's what I was trying to.
Yeah, that's what I did there, but I just I did it all together.
Okay. Then
So,
it will now go into the function.
yeah, so yeah, it calls the function,
Yeah, it goes
does
exactly.
whatever, yeah, and receives a return value. Now, if the return value is not zero, now if you look at what we did here, it's not going to be zero if any of these cases works. It's going to be one because we're returning yes or no,
Yes.
right? So if it is one, then just return. Just close the program, okay? Because we are done.
Okay.
Don't go ahead to do this. But if it's not one, I mean, if it's zero, you know that this basically says it is not equal to zero.
Yeah, true.
So else is saying if it is equal to zero,
Yeah.
then go ahead and
Call the second function.
yeah, call the second. Now note again that I'm not handling the first cases, but let's run this and see that it works. Right. Enter the first function as the operator. Right. Yeah, that works.
Yeah, it worked. Yeah.
Yeah. Now let's call a function in this second switch case. Let's see. Right. So you see,
It worked. Wow.
yeah,
Okay. Yeah, sorry. Can I see the main function again? I want to just clarify something.
the main.cd.
Yeah. Yes.
Okay. So you see,
Okay.
you made this three lines first.
Okay. Um. I'm still trying to look at something because how you call the first function, the first switch,
Yeah,
still like how you called it.
yeah.
I'm still kind of I'm trying to under how you called it.
You know that every function has a return value.
Yes.
Okay, can you see? Thank God for your please again. My cursor is on the name of the function. First,
So it's calling that function.
it's calling that function and it's passing the return value. Which
To
is
yeah.
read yes or no.
Okay.
So
Okay.
yes or no is an integer and the return value of first switch is an integer.
Yeah.
All right.
I think I
Now,
understand that.
all right. Okay. So, um, do you have any questions that doing debugging and stuff.
He said, no, I have no questions. Oh.
So this session is supposed to be about okay,
So he said,
right. This session is supposed to be about this, all we've done now. But we're also supposed to help you debug your code. You know, if you have any issues with your code that you need brainstorming or something.
nah, no, I don't have issues yet.
All right, that's cool.
Yes.
Wow, you're living the life, bro.
He said,
I'm just kidding. I said you're living the life.
yeah, yeah, true. But I know it will soon get harder though.
Right.
Then maybe I would actually, I don't know,
Yeah.
maybe we could, maybe if you guys will be having another program, like another meeting on
Yeah, we're having another session tomorrow. Same
tomorrow.
time.
Okay,
Yeah. So
yeah, I'll come with my problems. I'll come with my
all right,
problems.
that's fine. We'll be expecting.
Thanks. Okay. So you said about the links, yeah, about the link.
All right, so I'll stop sharing my screen now and I'll work on those.
Okay,
All
that's
right.
good.
So
Thanks.
Samuel,
Hello.
yep.
Hello.
All right. So let me work on.
Daniel,
Yep.
can you hear me? Can you guys hear me?
Your voice is a bit low.
It's an issue with my headphones, but okay. But then I think we've covered everything. So for tomorrow's session, it should be a bit earlier. It will be at 10 p.m. 10 p.m. East African time.
10
Okay.
a.m.
10 p.m. not a.m.
Eastern African time.
Yeah, that's 3 hours plus GMT. West African time
Okay.
it would be 8 p.m.
8 p.m. Okay.
Yes.
How do I share this?
But then I'll be posting the recorded session on YouTube, and then we'll be posting the link on Slack.
Okay.
Mm,
Kila time ni
okay, so I just